which is the common to 15, 21, and 35, and it has to be the least common. So that means when these numbers are put into the table, we find a number which is multiple of all these three numbers, and it will be the first number that will be the multiple of all this. That means that's why we say it's the least common multiple number. So whenever we try to solve LCM, whenever we try to solve the LCM, so what we do is usually take the number and make sure it is divisible. So this will be divisible by 5. This will be divisible by 3, 1. So that means 5 raised to 1, because there is only one 5 and there is only one 3. So that is 5 raised to 1 and 3 raised to 1. And similarly, again, that is 3 sevens are, that is 3 raised to 1 and 7 raised to 1. And simultaneously 5 raised to 1 and 7 raised to 1. So what we do in LCM, what we do, we take all the numbers, okay, all the numbers. So how many numbers are there? Different numbers. We have 5, we have 3, we have 7. So when we start with this, what we look after the numbers is the highest power. So now if we look at this numbers, the highest power everywhere is only 1. So if there were two threes like over here and over here, and the highest power amongst them was, suppose this was 2. Let us just say the number was different and this was 2, then we select the highest power. So always remember, for LCM, we select all unique numbers with highest power. With highest power. Fine. So now after this, what we'll do, we'll multiply every number. 5, 3 into 7. So that is nothing but 105. So now when we look at this table, so 15 sevens are, 21 fives are, and 35 threes are. So this is the least common multiple number. So we'll focus again that all unique numbers are to be considered while multiplication with their highest power. So here the only highest power was 1 raised to 1. Now similarly, when we look for highest common factor, we take only the common numbers with the lowest power. Fine, common numbers with the lowest power. So let's consider some numbers again. So let's consider this as 150 first number, then 210, and we'll select 375. Fine. So now let's do the simplest form. 5 30s are, 5 6s are, 2 3s are, and 3 1s are. So we can write this as that, as there are two 5s, so we can write it as 5 square into 2 into 3. And similarly for 210, which can be written as 3 into 7, that is 21. Again 2 into 5, that is 10. So that is 21 into 10 is your 210. And similarly for this, we can write as 5s are into 5, that is 25, into 5, that is 125, and 3. So now, how many common numbers now we have? Now what we are doing in LCM, we are selecting every number. If we select every number, then all the numbers will be what? 2, 3, 5, 7. But now in all these three numbers, 1, 2, 3, we have, when we are talking about HCF, we have to select only those numbers which are common in all the three numbers. Now if you look at the numbers, then 3 and 5, here also 3 and 5, here also 3 and 5, we have to select the only common numbers with the lowest power. Now the lowest power, if you look here, for 5 is nothing but 5 raised to 1, because we won't select 5 raised to 2, as it will become for LCM. For HCF, we'll select 5 raised to 1. So now 5 raised to 1, and for 3 also we have the lowest power as 3 raised to 1. So the HCF will be 15. Now, if it was supposed to be LCM over here, what we would have done, we would have select the highest uh, power. So that would be here 5 raised to 3, then 2 into 7. So there might be some number and this is your HCF, and this is your LCM. So this is the base concept when we talk about LCM and HCF. I hope that's clear. So moving forward, now sometimes what happens is there are numbers given in fractions. So that is x upon y, or anything that a upon b. Now we need to find out the HCF and LCM for such numbers. So there will be multiple numbers given, that is two or more fractions, as mentioned, for both LCM and HCF. First, we'll write down the formulas for this. Okay. For HCF, the formula is HCF of numerators upon LCM of denominators. So, so the best way to remember the formula is, if it's for HCF, the HCl will come in the numerator, and if it's for LCM, then LCM will come in the numerator. LCM of numerators upon HCF of denominators. Fine. So these are the two formulas. So let's try to understand one example. So suppose 4 upon 4 and 6 are two numbers, and 5 and 10 are two numbers. So now for LCM of two or more numbers, what we'll do, we'll carry out the LCM of 4 and 6 and HCF of 5 and 10. So again, we'll talk about 4 and 6. So 4 is nothing but 2 raised to 2, and this is nothing but 2 raised to 3. So we'll take the highest power, 2 raised to 2 and 3, that becomes 12. And when we talk about HCF of numbers, that is 5 into 1 into 1, and this is nothing but 5 raised to 2. So now the common number over here is 5. So your answer will be 12 upon 5. So this is how you solve HCF of numerator as LCM of LCF and LCM of two or more fractions. Okay. So now moving forward, there is one more. This doesn't come into HCF and LCM, but this is something which is necessary, because there are multiple questions based on this number of zeros, or they would ask you question like number of trailing zeros. Trailing zeros. Fine. So always they ask question in terms of how many zeros are there in 47 factorial, or maybe 96 factorial. Okay, so what is a factorial? Factorial is nothing but 47 into 46 into 45 until 1. So this is how big the number gets. So now whenever we need to find the number of zeros in such numbers, or in this factorials or trailing zeros, the key to this question is, we again divide this number, and we have to divide it by 5 for finding out the number of zeros. So now what we do is, we find the closest multiple of 5 near to 47. So the closest multiple of 5 here is nothing but 45, right? So that is 9, 5 nines are 45. Again, the closest multiple is what? Okay, so the closest multiple again here is nothing but 9 by 5. Again, you will have this as, again you will have this as, the closest is 10, so you will have a quotient of 1. So that is 9 plus 1, that is 10 zeros. Similarly, if we carry out for 58, suppose 58 factorial. So when we talk about 58 again, so the closest number here is 11. Again, the closest number here is nothing but 2. 5 2s are 10. Fine. So 5 11s are 55 and 5 2s are. So now you will have answer as 13 zeros. So let's try some questions for LCM and HCF. So let's try to solve one or two questions. So we need to find HCF of 36 and 48. So again, HCF will do, will take the common numbers with the lowest power. So for 36, it is 2 into 2, that is 4, 4 into 9, that is 3 into 3. That is 4 into 9, 36. So this is nothing but 2 square into 3 square. And similarly, for 48, it is 2 into 2, that is 4 into 2 into 2 into 3. This is nothing but 2 raised to 4 into 2 into 3. So this is nothing but 2 raised to 4 into 3. Now we'll look for the common numbers. So common numbers are 2 and 3 both. So now we'll select the lowest power, that is 2 raised to 2 into 3, that is 4 into 3, 12. Fine. So we can also solve for other questions as well. So let's look at the example of LCM. For LCM, let's try with this one. So we have to find LCM 22, 33, 45 and 72. So we'll start with this, that is 2, 11, 11. Fine. So this is nothing but 2 into 11. So similarly, this will be also 3 into 11. So this is nothing but 3 square, that is 9 into 5, 45. And this will be 24 into 3. So 24 into 3, how do you write down? So that is 72. That is 24 into 3. Again 8 into 3, that is into 3. Again 2 cube into 3 square. So now we have to select all the unique numbers, that is 2 with the highest power, 11 into 5 into 3. Now let's select the highest power over here. For 3, the highest power is raised to 2. Okay. For 5, it is 1. For 11, it is 1. And for 2, it is 2 raised to 4. So now we'll multiply all this number, that is 8 into 11 into 5 into 9, and you will get the answer. So here are some other questions you can solve. So this is the base fundamental for LCM and HCF. So there is one formula which comes in every exam. So that is all the speed based exam, that is LCM into HCF is equal to N1 into N2. So that is nothing but these are two numbers, okay, and when they are multiplied they form a product. So that is product of numbers. So product of numbers is nothing but LCM of those numbers into HCF of those numbers. So we'll input these values as per the formula. So the LCM of two numbers is 936, HCF is 4, and product of numbers, that is N1 into N2. So let's consider this as N2 into this. So this and this gets cancelled out, 18. So N2 is nothing but 936, that is 5. 18 5 is a 90 and 2 is a 36. So This is your answer. Moving on to the next question. So there are two alarm clocks ring their alarms at a regular interval of at 50 seconds and 48 seconds. If they beep together at 12 noon, at what time they will beep again for the first time? You can give 2 minutes for this and try this question. So moving on to the question. So what we want to find out in this question is the first beep at 12 noon. So let's say the first beep was at 12 p.m. Okay. So now the next alarm. Okay. So now the next alarm that will go together. Okay. So now if they want to go together, they need to have a common factor. Okay. So they need to have a common multiple. So basically what we have to do is we have to carry out the first beep. Okay. So first beep is done at 12 p.m. So now we want to find the next. So for this questions, we need to find the LCM. So LCM of 50, that is 5 into 10, that is 5 again, and 2. So that is 5 square into 2. And similarly for 48, we have 2 into 24 into 2, 12 into 2, that is 6, and 2 and 3. So that is 2 raised to 4 into 3. So now we'll select the unique terms, that is 25 into 16 into 3. So if we multiply this, we'll get 25 into 48. That is nothing but 25 8s are 200, 20, and that is 1200. So now 1200 seconds. So the question mentioned is in seconds. So now 1200 seconds is nothing but 1200 divided by 60, that is 20 minutes. Fine. So the next alarm should be at 12:20. So answer should be none of this. Let's have a look at the next question. So again, similarly, there are four bells, and we have to find how many times they will toll together in the next 3 hours. Okay. So again, we need to have a common multiple. So we'll go with LCM. That is 7 is 7 into 1. Then 8 is nothing but 2 cube. 11 is 11. Uh, 11 is 11 itself. And 12 is 2 square into 3. So we'll take out all the multiples. That is 7 into 2 cube into 11 into 3. So we'll get 21 into 11 into 8. 11 into 8. So we multiply this. So we get 21 into 88. That is nothing but 1848. Fine. So they have asked how many times will they toll together. So now if they toll together after this amount of time, like this in this seconds, right? So now we have how many seconds in 3 hours? We have approximately 10,800 seconds in this single hour. That means 3,600 seconds in 1 hour multiplied by 3. So we have this many seconds. Now every time it bells, after how many seconds altogether? That is 1848. So if you look at the options closely, so 18, let's consider this number as to be 18. So 18 threes is somewhere around 54. So that's not possible because it's half the value. Okay, so we want to find the maximum time, like how many times it would have done in the next 3 hours. If you do 4, that is 72. So again, that's not possible. If you consider 5, and 18 5 is somewhere around 90, and 18 6 is again a number which will be more than 10,800. So the answer will be 5. Let's move to the next question again. So this is the same question. Again, we have to find out at what time they will switch the lights together. Fine. On Ashok Mark, three consecutive traffic lights change after 36, 42, 72. If the lights are switched on at 9 a.m. sharp, at what time will they change simultaneously? Hello? Hello, am I audible now? So 48, 16 threes are, and 96 plus 4, that is V2, 1008. So 1008 again at what seconds? So if we have to do in seconds again, let's look ahead. So what's the closest number over here? Okay. Just a second. So the LCM over here, it will be 504. That is 2 square into 3 square. And you have again 2 into 3 into 7. And similarly for 72, you will have 236, 218. So 2 nines are 3 square, 331. So that is 2 into 8 into 3 square. So if you take all the terms, 504, and 504 is nothing but, if you look, that is 480 is 8 minutes. Okay, so this is 480 seconds is 8 minutes. So how many additional time do we have? Over here is 24 seconds if we need to get 504. So this will be the answer, 504. Now again the same formula, LCM into HCF is equal to N1 into N2. Okay, the LCM of two numbers is 1890, HCF is 30, one of the number is 270, and this number will be X. So this is 31 this is 39 and finally 1890 upon 200 and upon 9. Okay, sorry, upon 9 is 210. So your answer will be, according to this formula, is 210, option A. So one more question. Again, we need to find the starting point. So there are three runners running around the circular track, can complete one revolution to 4 and 5.5 hours. So now let us look at those numbers carefully. We have 2, we have 4, and 5.5 is nothing but 55 upon 10. So we can also say that this is 11 by 2. Okay, so this is 11 by 2. So 11 by 2. Fine. So we have to find the LCM. So LCM of all these numbers. So let's start with this. This will be 2. This will be 2 square. Fine. 2 square. So now whenever we find out LCM of a fraction, what we have to do? We have to take LCM of denominator and HCF of numerator. So these, if you look at these numbers carefully, there are two numbers we can consider. That is 11 and 1 and 2 and 1. So when we consider LCM for this will be nothing but 11, and HCF, that is 2 and 1 are 1. That is HCF here will come as 1. So we have to select here as 11. So now again unique numbers with highest power. So that is 2 raised to 4 into 11. So this will become 4 into 11 is 44. So we have almost covered all the concepts regarding LCM, HCF, the fraction thing, the formula, and also with number of zeros. So here are some additional questions you can solve for your reference. So that's it for LCM and HCF. These are the only common things that one need to be careful while studying LCM and HCF.